Swayam Prabha. Digital India. Educated India.
Very good morning, good afternoon and good evening my dear friends. Welcome to the TQM2 lecture series, which is another NPTEL MOOC, and as you know it is a 20 hours program. So, each week you do 5 classes, each of half an hour duration, and after each week you have assignments. So, it will be 8 assignments plus one end semester examination or end term examination or final examination, whichever you name it. I am Raghunandan Sengupta from the IIT department, IIT Kanpur. So, we will be starting the 5th lecture, and as you remember that we have discussed that all the things related to design of experiments and further related topics in TQM and other relevant areas. So, you basically need to understand the concepts of the 4 main distributions, which is the normal one. Obviously, we did discuss the discrete and the different type of continuous distribution. They would have implication for the hypothesis testing later on, considering the central limit theorem to be true. I did mention central limit theorem very fleetingly, but its essence, without going to the proof, its essence and its importance will come out later on, and we do more and more discussion about that. So, do not worry about that, we will do that. And the main 4 distributions was normal, and from the normal we had basically the t distribution, the chi-square and the f. And if you remember, I did mention it, and I will be repeating it time and again, that is anything to do with the mean value or the first moment for the particular distribution would be related to the z or the t, and anything to related to the standard deviation or the variance, which is the second moment, would be related to the chi-square and f. And I also did mention that the concept of degrees of freedom, that will become very apparent as you start going to the depth, which I will try to cover in lecture 5 and hopefully wrap it up in lecture 6. So, consider now the problem is like this. Initially, and if you see the slides or the document file, Word doc, so that will make it very clear to you. In the initial part, we had in the last lecture, 4th one at the fag end, we had to do something to do with the mean, and the standard deviation of the variance was known. Now, we will basically consider something to do with the mean, with the standard deviation and or variance not known. It may be a repetition what we did in lecture 4 end part, but please bear with me. So, we would basically have a best estimate from the sample or the best proxy from the sample, which will try to basically be the best estimate considering unbiasedness and consistency. Those properties have to be checked, which I did mention are important, but I did not go through the proofs, that is not required for this course. So, you had basically S dash and S dash is the case when the best estimate for the population variance using the standard error or the so called variance of the sample, considering the mean value is known, and in the other case when the mean value is not known, you use S without the dash. This is what we are considering, because if we read the top line, it basically mentions where I am hovering or I am highlighting it. It basically means confidence interval for mean considering the standard deviation is unknown. So, this confidence interval, obviously once you understand, it will have a very simple understanding in the hypothesis testing. So, we have the following facts, which means S square, which is the square of the standard error for the sample considering the mean value is unknown, would be given by 1 by n minus 1, because minus 1 is coming due to the fact that you are losing 1 degree of freedom. and then it would be summation, and the sum would be of the squares of the values of the difference between the random variable and its mean values. Mean value is the sample mean, which is the best proxy for the population mean. We also know for the normal case x bar, which is the sample mean, and the s without the dash square are independent, and obviously we will know that x bar n is normally distributed with mean mu, and variance is sigma square m by n, hence it can be converted into a standard normal or z distribution. So, once this is done, you can easily find out that you can get two type of distribution from them. One is basically the case of the chi-square, where I am not going to highlight, I am just hovering the pen above. So, this electronic pen. So, this is basically the chi-square. Now, you note down the degrees of freedom. It has lost 1 degrees of freedom because you are trying to find out the ratio of the square of the standard error divided by sigma square for the population or the variance of the population. But the square which is in the numerator is basically the standard error whole square, considering the mean values unknown. So, I will be repeating these time and again, please bear with me. And if you remember the t distribution, which t distribution is basically the ratio of, in the third and the fourth lecture we did discuss the ratio of a z distribution divided by the square root of a chi-square divided by its degrees of freedom. So, now, so the numerator part, where again I will try to highlight. So, this part, the numerator of this highlighted equation, numerator is basically a standard normal, and in the denominator, which where the cursor is basically a chi-square, but that chi-square divided by its degrees of freedom, but the chi-square is already we know is of n minus 1 degrees of freedom. So, obviously, you will get a t distribution with n minus 1 degrees of freedom, which is very logical. Now, given this, you will basically try to find out the lower limit and the upper limit, considering that within that bound, if you remember I did discuss within that bound the overall confidence that the upper limit and the lower limit would have the so called parameter of the population within that is given by 1 minus alpha, which is the confidence level, and if you find out the confidence level we want to, so we have to basically formulate it accordingly. So, probability of the lower limit corresponding to the t distribution and the upper limit of the t distribution, which is basically upper limit being t, now mark my words carefully, n minus 1 is the degrees of freedom, and comma alpha by 2, because this is the area which you have to cover more onto, if you are looking at the distribution from your end, and this is t, if you remember, has a mean value which is 0, onto the left are the negative values, on your right are the positive values. So, if you go subsequently along that x line which has the t values, so obviously there would come a certain upper limit where the t values leave aside the degrees of freedom, we have already discussed that. It will be alpha by 2 corresponding to the case that the area still to be covered is alpha by 2. Now, if you come on to the left hand side from your side, which is the lower limit, it will be t, again n minus 1 is very obvious, it will be 1 minus alpha by 2, which means the overall area to be covered more further on to the right. Now, you may be thinking that I had been mentioning that the only distribution, and as you know, which is basically absolutely symmetric, is the normal distribution, but t distribution, if you remember, if you increase the sample size and even for small sample size it is symmetric, hence this total confidence level is 1 minus alpha. So, the overall area left is alpha. So, it is being equally divided onto the left hand side and the right hand side with values of alpha by 2. So, if you basically do some juggling, very simple, like taking the denominator, the numerator and cross multiplying and all these things. So, at the end of the day, the result is where I am highlighting, let me highlight is further on. So, the lower value would be x bar n minus s n divided by square root of n into t n minus 1 alpha by 2, because as it is symmetric, hence 1 minus alpha by 2 and alpha by 2 would be of the same numeric values, but with a sign being there for 1 minus alpha by 2. So, hence this n minus sign is coming, where the cursor is now being hovered around. So, that would be the lower value, and the upper value obviously would be x bar n plus, because that is on the right hand side from your side, it would be plus s n by square root of n t n minus 1 alpha by 2. So, that would basically be the lower limit, upper limit. Between that you will have the mean value, and that the total confidence level is basically 1 minus alpha. Now, if somebody wants to find out the difference between this, the lower limit and the upper limit and the length of the confidence interval, obviously it will be the upper value minus the lower value. So, basically x n bar cancels, it will be twice of x s n divided by square root of n into t n minus 1 alpha by 2. Now, consider, now we had seen in these two examples last day and today that the main focus was to do with something with the first moment, which is the mean. Hence, we use the z distribution to find out the confidence interval of the mean, provided the variance of the standard deviation of the population is known. In the second case, we tried to find out, just we finished few seconds back, is basically to find out the confidence interval, and for that we use the t distribution with 1 degrees of freedom being reduced, which is basically going from n to n minus 1. For the case when something to do was to find out the confidence interval of the mean value of the population, provided the standard deviation or the variance of the population is unknown. Now, we switch our overall discussion to do something with the confidence interval study and the study of the interval estimations to do with the standard deviation of the population, which is the second moment. Now, in this case again we will have two scenarios. Scenario 1 would be when the population mean is known, and scenario 2 is the population mean value is not known. So, let us now proceed. So, as shown, the confidence interval for sigma when mean value is known. So, obviously, we will use with a little bit logic we can understand, we will use s dash square, because in an s dash we do not lose 1 degrees of freedom, and because the mean value is the population mean. So, s dash is given. Now, when we try to find out the ratio of s dash square by sigma square, as we did in the last case, but in that case the ratio in the numerator was s without the dash. When we do try to find out the ratios, it becomes a sum of the squares of standard normal deviate, but in this case it becomes a chi-square, obviously as in the last case, just the example we considered, but without any loss of degrees of freedom. So, it will be chi-square with n degrees of freedom. Now, when we want to find out the interval, so obviously the interval would be, which I am again highlighting for the case of the standard deviation. So, it will be, when we put, we have not yet simplified it, it will be basically chi-square n, because it is n is the degree of freedom. Now, here note down one thing, till to be covered is 1 minus alpha suffix 1, and on to the right is n comma, the suffixes are alpha comma alpha by 2. Now, the alpha 1 and alpha 2 have some relations with alpha, definitely, but we are assuming, and rightly so, the chi-square is non-symmetric, but we will make some assumptions further on, which will again say it repeatedly, and such that you understand the concepts. So, when we simplify the overall, so I will remove the color from here, because that was the initial discussion we wanted to do. Now, the actual confidence interval now becomes this. So, n s dash square by chi-square n comma f alpha by 2, which is the lower value, and the upper value is again n s dash squared chi-square n 1 minus alpha by 2. Now, for simplicity, to find out the shortest interval, as if you read the lines which is given, we can basically assume alpha 1 is equal to alpha 2 is equal to alpha by 2, and we can solve the problems accordingly. So, hence the interval concepts with respect to the standard deviation or the variance of the population becomes this n s square, which remains same as this one, n s square again remains the same as the first one. Only note down the changes, it will be chi-square, n degrees of freedom remains same, there is no change, but alpha by 2 and 1 minus alpha by 2 gets replaced by the corresponding values, which is alpha by 2 and 1 minus alpha by 2, because we are assuming alpha 1 is equal to alpha 2 to find out the shortest distance, such that is equal to alpha by 2. So, this is done. So, done in the sense I have just we will be coming back to that later on time and again. Now, we want to find out the confidence interval with respect to the the standard deviation given the population mean is unknown. So, if the moment the population mean is unknown, obviously we will know we would not be using the S dash, but we will using the S without the dash. So, in that case S dash becomes 1 by n minus 1 and the summation remains as it is, but only in the case here mu is being replaced by the sample mean. So, once you do the same concept and go to the logic. So, the ratios of the S square by sigma square, and you can prove it, it becomes a chi square with n minus 1 degrees of freedom. Once you replace it, again remembering it will be again the same concept of alpha 1 and alpha 2 and so on and so forth. So, once you solve the problem, it becomes this, which is, now note down the simple changes. In the initial case it was n here for the case when you want to find out something to do with the confidence interval of sigma square. So, it was n, now it is n minus 1. In the previous case it was S dash square, now it is S square. Okay, by the way, just for your information, this small n which is the suffix for S basically denotes the sample size, nothing else. So, do not be confused about that. Now, in the right hand side also I am only discussing the numerators. The right hand side also the same replacement has taken place logically. N has been replaced by n minus 1, S dash square suffix n has been replaced by S without the dash square suffix n, and in the denominator the things have changed accordingly. Alpha by 2 remains as it is, 1 minus alpha 2 by 2 remains as it, but the degrees of freedom which was n initially has changed to n minus 1. So, this would basically be the lower limit and this would be the upper limit, and basically the sigma square value would always lie between them, with 1 minus alpha being the level of confidence. Now, I want to do something. So, let me pause here and let me discuss few examples. I have not written them, but in order to make you understand. So, if you listen to me and you will understand. Say for example, in the first example where we had to do something with the mean value. So, you had basically two distributions Z and T. So, those examples could be thought about as, say for example, you are producing some goods in the factory and you want to find out what is the average weight of the jam bottles or the jelly bottles or some tie rods which are coming out, what is the overall length, or say for example, in carton boxes are being packed, what is their weights and all this thing, or say for example, some very fine instrument is being produced. So, what is the precision of this instrument, what is the inner dimension of a tube which is coming out, which is to be used for oil exploration. So, all these things can be thought about, very simple examples. So, when you want to do something to do with the average dimension, we use basically the Z or the T distribution. In the second case, when we consider something to do with the variance, it is to find out what is the variability or the dispersion of the average output or the value of the output which is happening. Maybe you are producing some goods, again the same example, packaging jam bottles, jelly bottles, packaging carton boxes, trying to find out the length of the tie or whatever, we want to find out what is the variability. So, based on that we will use the chi square, whatever the degrees of freedom would be, it will be n or n minus 1 depending on the information set which we have. Information set, I mean population mean being known, population mean being not known. Now, consider a slight change in the overall the concept. You have two factories and the same products are being manufactured, which will again repeat, it is either filling up a jam bottle, jelly bottle, trying to find out the weights, or trying to basically weigh the carton boxes which are being packed, or trying to find out the length of the tie rod, or trying to find out the inner dimension of a very fine pipe which will be utilized for oil drilling. Here the comparison is now being happening, that two factories are producing, two locations are producing. So, what is the overall variability in the processes? So, if there is a variability, obviously we will consider the something to do with the variance. So, when you are trying to find out something to do with the variance, it will be something to do with the ratios of the variances. When it comes to the ratios of the variances, obviously you will see very logically that we will be using the F distribution. Now, if you remember the F distribution, I did mention that I remember that you will basically try to use 2 degrees of freedom m and n being the sample size for the sample 1 and n being the sample size of sample 2. Now, these degrees of freedom m and n will change. How will they change? Let me proceed, it will become clear to you. So, here is the background and now I am going to discuss. So, the problem is, I will highlight first, you want to find out something to do with the difference of the mean when both sigma 1 and square and sigma 2 are known. Okay, just hang on. So, here what would be relevant for you is that first to discuss the concept of the differences of the mean rather than the variabilities ratios. I will come to that variability ratio, because I thought that I have already discussed the example of when I did mention about trying to find out the weight of the jam bottles. So, rather than the variability, let me put the same example in a different perspective. The overall environment remains the same. So, say for example, in the last example which I did discuss, you are trying to find out compare the variability. Rather than trying to find out the variability, how about finding out the differences on the average values? So, this is the framework of the problem, and let us see that how the concept of trying to find out something to do with the difference of the mean would be coming up. So, I will come to the F distribution later on, please bear with me. So, consider we have two populations x with certain mean and certain variance, and the mean being mu suffix 1. When I mention 1, 2, 3, it will be with the suffix, if not I will basically specify it, please. And the variance is sigma square suffix n, and y is again mu 2 sigma 2 2, the second 2 is basically for the suffix, and from them you take up sample size of m as in mango, n as in Nagpur. You take sample size of m and n, it can be n suffix 1, n suffix 2, it can be equal also, it does not matter. Number of observations have been taken up such that we know definitely, because if they are normal, then obviously these two would definitely be true. One is the mean value of the first set of observation from the first population would follow a normal distribution with mu 1 as the mean value and sigma square suffix 1 divided by m as the variance. So, based on that, once you find out, the distribution is this, which you can understand. Now, when we go to the second population, take up a sample size of size n, then y would basically, what is the average, y bar suffix n would be the average of the sample size. It will be distributed with a normal distribution with a mean value of mu suffix 2 and variance of sigma square suffix 2 divided by n. So, this is what we have. I will put a different color here in order to make you understand. So, these are the distributions for the sample means for the first, sample means for the second. So, so if this is clear, I will remove the colors and proceed further on. Now, when you want to find out the difference of the sample mean, it will be to try to understand the difference for the population mean, what you will do is find out the difference between the sample mean compare with the population mean difference. Now, any convex combination or normal distribution would always be normal. So, in that, and this is a very unique property of normal distribution. So, once you consider that, the numerator of this, now let me go very slowly, numerator of this would basically a difference of two terms. The first term which is in the first bracket is the difference of the sample mean, and the second term within this curved bracket would basically be the population differences. So, obviously, if the population differences are 0, then obviously the sample mean differences should also be 0 technically. Now, when I am trying to find out the differences, this is the random variable. So, obviously, it means the differences of the two random variables would have a normal distribution. And now the question is that what are their actual averages and variances. The average is mu suffix 1 minus mu suffix 2, and the actual variance of this difference between the sample mean would be sigma square suffix 1 divided by m plus sigma 2 suffix square divided by n as shown here. So, if I basically go into the actual concept of trying to find out the normal distribution, which is now z, the pink colored highlighted formula. So, this is basically the difference between the random variable and its mean value divided by, if you remember here, this is divided by its standard deviation. So, this is the standard deviation, so it will be normal 0 1. So, the confidence interval if you put in the formula, it becomes, I will just remove the color in order to proceed and highlight it here. Let me use some other color, which one? The light green. So, let us use the light green one. So, this is the probability of the average values or the difference of the average values for the two sample minus, now again see a very simple case. In the other case, when there was only one population, it was basically z alpha suffix alpha by 2 into sigma, which is the population mean, divided by square root of n, because that was sigma square by divided by n was the sample means variance. So, in this case again the second part, which is under the square root, is basically the replacement of sigma by square root of n. So, that is less than equal to the sample population mean difference, and again on the right hand side, in place of minus, this what is the sign is there before z alpha by 2, it becomes plus z alpha by 2. So, these are the limits for the lower limit and the upper limit, considering that you want to find out something to do with the difference in the population mean using the sample means as the best estimate. And obviously, that would be equal to 1 minus alpha. Now, when we want to find out something to do with the, I will come to the F distribution, please hang on. When we want to find out something to do with the difference in the population mean, considering the standard deviation of the variances are unknown for the population, but they are equal, then obviously the question will come up that why did I mention that? Now, think intuitively and it will come out very easily. If the population if the variances are unknown, so obviously you have to replace them with the corresponding values of the sample. So, in the sample case, so obviously this is true where it is being highlighted, this is true, which we have already discussed. Now, very interestingly, this would also be true because that is equal to the t distribution with m minus 1 and n minus 1 as the degrees of freedom, considering you have lost 1 degrees of freedom in both the cases, because you are now using s without the dash in both the cases. So, s without the dashes is basically the s m comma 1 and m comma 2. See, this 1 and 2 basically signify from which population you are picking up. So, these are not the s with the dash, they are s without the dash. So, once you plug in, the pooled sample variance would be given by the formula, which I will try to highlight first. So, which is the yellow color. So, this is the pooled sample variance with the corresponding s dashes coming for both the from the variances, and this total combined reduction in the degrees of freedom would be 2, one from the first population, one from the second population. Hence, now the total combined degrees of freedom is m plus n minus 2. So, once you have this, so once you replace that in the limit confidence interval, the formula becomes this difference in the sample mean. Now, in the other case, when the population variance was not known, you use the t distribution with 1 degrees of freedom being lost, and then you proceeded. See, here is exactly the same thing. This is t distribution, obviously with the minus sign, because this is the lower limit. Now, watch it very carefully. In that case, in the first case, when there was only one population, there was only 1 degrees of freedom loss, which was m minus n or n minus 1, whatever is m minus 1 or n minus 1. Here it is m plus n, the combined sample size, minus 2 because you are losing 1 degrees of freedom in both. So, this is the suffixes which are coming. SP is the S suffix p is the pooled variance, and obviously it will be 1 by square root of m plus n. And here on the right hand side also the same formula, but with a plus sign coming in front of t and all the suffixes. So, once you solve it, you are able to find out what is basically the confidence interval and solve your problems accordingly. So, with this I will end the fifth lecture and continue discussing more about the confidence interval and hypothesis testing in the sixth lecture, and so on and so forth. So, try to wrap up as soon as possible and try to continue the design and experience. So, once you understand that, it will be much easier for all of us to proceed a little bit fast in the case of design of experience and the concepts accordingly. Thank you very much. Have a nice day.